Hey guys, welcome back to UVM Testbench code from scratch. So in the last video we have seen UVM Testbench architecture and the flow how it will be. So now let us get into UVM phases. UVM phases are referred as the step-by-step execution of the UVM testbench. It means there are different phases of execution. So UVM testbench will follow the sequential order of execution. If you see here, build phase, run phases and cleanup phases are the three main categories in phases. Build phases consists of build phase, connect phase and end of elaboration phase. Run phase consists of start of simulation and run phase. Cleanup phases are extract, check, report and final phases. Build phase is going to build the lower components of the test bench one after the other. Connect phase is going to connect those. We are going to write the connections in the test bench in the connect phase where the connections are going to be established. End of elaboration means we have made the connections, they are correct. Now it is ready to generate the UVM hierarchy or the UVM tree. Then comes the run phases. Once the simulation started, means once the packets are generated and we start driving those packets to the lower modules till the DUT, the start of simulation and run phases come into picture. In the run phases, you can see here from the pre-reset, then configure, then main phase up to shutdown phase. The heart of all the phases is run phase. It takes much time. And after the run phase, once the simulation is get completed, we have cleanup phases, means we need to report, we need to extract the results, we need to check the results. So for that, extract, check phase, report phase and final phases are there. So this is the brief introduction to this UVM phases. Now let us get into our D Flipflop code where we left with, and we need to start writing these phases in our test bench. So far we have written the TB top and we have instantiated our DUT as well as interface, and also we have created the clock. And in the interface, as I said, we need to declare all the input and outputs with a logic keyword, logic declaration. Now test component. So if you look at the test bench architecture, we have TB top, that is a module, test, environment, agent, scoreboard, sequencer, driver, monitor are all classes, and interface is of type interface itself, and DUT is a module. Now these from test to sequence item, what are all the test bench components we have? We categorize these into a UVM component and UVM object. Which are all the UVM components here? Test class, environment class, scoreboard, agent, driver, monitor, sequencer. These all are UVM components. Sequence item and sequence are UVM objects. Why we are going to call those two as UVM objects means these two are dynamic in nature. Once the simulation is going to be started, sequence item and sequence are going to generate the packets and it will drive to the next lower component, to the sequencer. So sequence and sequence item are dynamic in nature, and those packets which are going to be generated are destroyed once the simulation get completed. That's why sequence and sequence item are not static. So we call it as objects. Components are test, environment, scoreboard, agent, monitor, driver and sequencer. These are static in nature. They are going to be present at the simulation time, even after the simulation time. That's why they call it as components. So the test is a component. So I have written here, test class is a UVM component. You can write it as UVM component. So these UVM components will be having phases. Sequence item and sequence are UVM objects. There will be no phases in objects. So let us start writing the build phase for the test component. So build phase. Build phase is a function void build underscore phase, and it will take the argument as UVM underscore phase. This is the syntax for the function. Let me write in function, and in between we are going to call the base class with super dot build phase, and we need to pass phase. So this is how the basic structure of a build phase function look like. And here in between in the function, we need to create our lower modules. So we need to create our lower components. So this is a test class. You can see here in the architecture diagram, the test class consists of environment. Within the test we have env. So environment class is there over here. The name of the environment is dff_env. We need to instantiate that lower module and we need to give the handle. I am giving it as env. Now we need to create that component over here in the build phase. env is equal to dff_env is the class name. We need to use : type_id create. So this will be called as type id create method for creating an object. Here we need to pass again two arguments for this. One is env comma this. So this is how we can create our lower module. We can create this environment which is come under the test using type id create method. The difference between creating the lower component using new method and type id create method, let us discuss in other video. So now let us move on to the next component, that is environment. You can see again the block diagram here. env consists of scoreboard and agent. So I have instantiated dff agent and dff scoreboard, and I have given the handle as agent and scb. We need to create those two under the build phase of environment now. So agent is equal to dff agent using type id create method. We need to pass agent and this keyword. Similarly, scb for the handle for the scoreboard, dff scoreboard type id create method I am creating for this class. So this is under environment because of we have scoreboard and agent. Now let us move on to agent. Agent class consists of driver, monitor as well as sequencer. So we need to create driver, monitor and sequencer as having the handles drv, mon and sequencer, and I am creating those in the build phase. You can see over here. And then let us move on to driver. This driver is also a component. Driver is a UVM component. But if you look at the block diagram, here driver does not contain any lower module, right? Within the driver, is there any test bench component there? No. That's why in the build phase we are not going to create anything, right? But for the driver we require our sequence item class. We need to pass the name of the sequence item class. Why? Because this driver has to know which sequence item or the transaction we are going to pass from the sequencer to driver. And then comes monitor. Again, if you see the block diagram here, this monitor consists of no submodules. Monitor is standalone. So there is no other components over here for instantiation. And then comes sequencer. If you see sequencer here, this sequencer consists of sequence and sequence item, but this sequence and sequence item are not components, right? So here I am just passing the sequence item as an input to the sequencer, and let us see how to create sequence and sequence item in the further video. And then comes sequence. Sequence is a object. This is UVM object class. Okay. Since it is a UVM object class, there will be no phases. So we are not going to write any phases over here. In the sequencer, there is no requirement of phases. Why? Because we are not going to write any phases in the sequencer by manually here. The base class consisting of all the phases, and that is sufficient. And as I said, sequence is a object class, so there will be no phases. Sequence item is also a object class, and there will be no phases. And then comes scoreboard. So this scoreboard is again, as I said, it is a UVM component class. This is also UVM component class. So within the scoreboard again there will be no submodules. So no subclasses we can say. So there will be no instantiation of any lower modules, and also in the build phase no need to create any modules. Now after the build phase, connect phase will come into picture. In the connect phase, what we are supposed to do? So in the build phase, what we did? We build the environment. We build the submodules by instantiating the lower module, as well as we created an object for that. Now in the next phase, connect phase, what we are going to do? You can see the block diagram here. Wherever I have shown the connection, you can see sequencer and drivers are connected. Sequencer and driver are connected with the TLM ports, and similarly monitor and scoreboard are connected. This monitor scoreboard connection we need to make using analysis ports. So if you see the sequencer and driver, the connection has to be made, and where we need to make this connection? We need to make the connection right in agent. Means agent consists of sequencer and driver. The connection between the sequencer and driver has to be in agent. So in the agent class, we are going to write connect phase, and in the connect phase, we are going to make the connection. Similarly, scoreboard as well as monitor connected using analysis ports. That connection will be done in environment. So let us see those concepts of connect phase in the next video. Thank you.